The modern portable gas detector is a state-of-the-art piece of equipment that has incorporated modern technology to ensure that it is reliable and user-friendly. Many of the latest designed gas detectors have a multi-channel detection system with an on-screen display, which usually displays percentage of LEL, percentage of oxygen by volume, H2S in ppm, and carbon monoxide in ppm. H2S and carbon monoxide are usually measured by electrochemical sensors. Oxygen is measured by a capillary pore fuel cell, and flammable gases are measured using a catalytic bead sensor. Although as the AGT you will normally be involved in the use of portable gas detection systems, you should be aware of some of the other types of gas detection systems that are in use. Many fixed gas detection systems use infrared open path gas detection systems, which are non-aspirated gas detection systems. The gas detectors send out a beam of infrared light, detecting gas anywhere along the path of the beam. Usually, there are separate transmitter and receiver units at either end of a straight beam path. The strengths of this type of gas detection include continuous monitoring of the area. However, the detector can be affected by strong sunlight, which can confuse the analysis and cause spurious alarms. Forward-looking infrared uses the natural reflection of surrounding objects to analyze the absorption of the gas. FLIR cameras can also be used to identify hot areas where a fire may have been initiated, sounding an alarm in the control room for investigation. FLIR cameras can provide continuous monitoring, however they are also susceptible to outside sources of light, such as flash photography, which may cause spurious alarms. Non-aspirated gas detectors are normally used for the detection of flammable gases, and are rarely used for toxic gas detection. Infrared gas detectors are very useful in detecting flammable gases in confined spaces that have purged atmospheres, as they do not require a percentage of oxygen to analyze the gases. With the latest technology and microprocessors, these detectors are very reliable and rarely produce spurious results. However, it is important that you are aware that outside influences from vapors, such as chemical cleaning fluids, may affect the analysis. Aspirated gas detectors require a percentage of oxygen in the atmosphere as the gas passes over a heated platinum wire to detect flammable gases. Under normal circumstances, these types of gas detectors are reliable, but without 12% oxygen content, the heated wire cannot detect the flammable gas. Therefore, as the AGT, you should be aware of the differences in the use of aspirated and non-aspirated gas detectors. If a representative gas sample is required in a nitrogen-purged confined space atmosphere, an infrared or similar non-aspirated gas detector should be used. Most gas detectors give both audible and visible alarms, and some also have a vibration alarm. Most modern gas detectors also have an integral diaphragm pump to ensure reliable sampling. Many of the newer models have the ability to capture data logging and even logging to track exposure, which is hugely valuable when working in toxic atmospheres. Generally, gas detectors are intrinsically safe and can be used in hazardous zones. They have a molded outer casing to prevent damage to the detector. However, before carrying out any gas testing on your site, you should always read the operating manual for your gas detector and understand not only its operation, but also its limitations. A gas detector can only keep you safe if it is used correctly. Before beginning gas testing, there are various checks that should be carried out. Firstly, all gas detectors require calibration to ensure that the results recorded are true. This is done by what is known as the bump test, and test gases are used to calibrate the detector. Calibrating gas detectors is normally out with the remit of the AGT, and is usually carried out by a person who has been trained in the calibration process. Most modern gas detectors will indicate on the screen when the next calibration is due. It is your responsibility to ensure that the gas detector is within its calibration date. The first check should be the physical condition of the gas detector. Is there any damage to the casing? Are there any cracks on the screen? Is the probe nozzle clear, and is the hose in good condition? If there is a water trap fitted to the probe, is this empty and dry? If the detector is damaged, you should report the damage to your supervisor as soon as possible and immediately remove the detector from service. Next, press the Start button on the detector as shown in the operation manual. One of the first things you will see is the amount of charge left in the battery. Always ensure that the gas detector is fully charged. This is important if you're carrying out testing of a confined space where you may have to enter a complex configuration using breathing apparatus. The last thing you need is for the gas detector to run low on battery life, and you have to exit the confined space to recharge the battery. Most modern detectors will automatically run through the low and high-level alarm settings before settling down to display the fresh air screen. 20.9% oxygen, 0% LEL, 0 ppm H2S, and 0 ppm carbon monoxide. You will now be asked to block the probe by placing your finger over the end nozzle. The detector pump will continue until a vacuum is pulled, showing that the integrity of the hose is okay. If the hose is damaged, then the sample gas is not being pulled through the probe nozzle, and the integrity of the test will be at risk. If the detector displays an error message, please refer to the manufacturer's instructions in the first instance. If the error cannot be corrected, the detector should be immediately removed from service. When you're satisfied that the detector is working correctly, shut the gas detector down before moving to the worksite. Once near the worksite, wait in the fresh air for 10 minutes for the gas detector to reach the ambient temperature, and then repeat the fresh air test. If you are moving the gas detector from an air-conditioned control room or office to a hot or cold environment, be aware that the change in temperature can cause condensation to form in the gas detector and produce erroneous results. Always give the detector time to reach the ambient temperature of the space that it is to be used in. If at the fresh air test you do not get the expected results, try the detector again in another fresh air area. If the results are still not what you expect, notify the control room, return the gas detector for recalibration or repair, and use another calibrated gas detector. Please note, if you have to replace the gas detector, you must carry out the checks again using the replacement detector. Let's try an exercise on the use of gas detectors. When carrying out the fresh air test near the worksite, what results would you expect to see on the gas detector screen? Select the gas screen that shows the expected results. When you're happy with your answer, select the Submit button. That's correct. Let's look at the actions to take when the gas detector shows unexpected results when testing the atmosphere at the worksite. Look at the display screen on each of the gas monitors shown. During the gas test, if the monitor displays results such as these, the work area is not safe. As the AGT, you must report this occurrence to the central control room to raise the alarm and inform all personnel in the vicinity to evacuate the area. An investigation will be carried out to determine and subsequently eliminate the cause of the abnormal results. Over recent years, gas detector technology has made major advances, with microprocessors being incorporated, components becoming smaller, and the ability to perform faster and more reliable than older models. However, you should be aware that some sites may still have older gas detectors in use. In the older catalytic gas detectors, a platinum wire is heated and the sample gas is passed over this. As the wire oxidizes, the value of the electrical current changes and is linear to the percentage LEL of the test gas. However, this type of system is susceptible to poisoning by silicones and other vapors, which can prevent the correct oxidization and true values of the percentage LEL. Another drawback of these older models is that they are susceptible to the effects of sudden shocks if they are knocked against plant and equipment or dropped. The platinum wires are very delicate, and can easily be broken. The catalytic detectors also give poor results at the UEL range. Both the old catalytic detectors and the modern catalytic bead sensors require a minimum of 12% oxygen to be able to measure flammable gases. It is essential that you are aware of this requirement. If you are testing for flammable gases in a nitrogen-purged atmosphere, you must use a different type of gas detector, such as an infrared detector.